start. We have main engine start. 4, 3, 2, 1, 0, and liftoff. The liftoff of the space.
In our natural pursuit of knowledge, space has always mystified and beguiled us. Over the past 5 decades, we've pushed the final frontier inevitably onward into the ether. The cost has been colossal. Now every day, new data, new conclusions, and the thirst for deeper exploration propel us inexorably onward. The advantages of the discoveries made through space travel are myriad, but the fundamental curiosity as to what is out there will always fascinate and taunt us. Come with us now into the unknown and discover the disappearing frontier. Coming up in this edition, condensing 30 hours of spaceflight time into a few short minutes. Disappearing Frontier takes you on a journey to the beautiful outer giant Saturn, planet of the rings. A heartwarming story about a little boy who's using space technology to keep his cool. We resume our story on Faith 7, Gordon Cooper's 1963 flight to test the efficiency of a human being as a primary component of a spaceflight system. And using computer animation based on NASA's research, we take a flight around one of the coldest, oldest moons of Saturn, Miranda. On August the 25th, 1981, Voyager 2 arrived at Saturn. The spacecraft had journeyed 1 billion miles from Earth in 4 years. Voyager 1, in its November 1980 encounter, first revealed the beauty and complexity of the ring planet and its family of satellites. Now, Voyager 2 will explore specific targets in Saturn's realm. This computer-simulated film shows a time-condensed view of Voyager 2's tour of the system, 30 hours in 4.5 minutes. We join Voyager 2 on its approach as the spacecraft's cameras and other instruments scan the planet and most of its 17 known moons. The ultraviolet spectrometer looks at regions around the sunlit and dark edges of the planet, studying Saturn's emission of ultraviolet radiation. The instrument's field of view is represented by the rectangle moving up and down the northern limb as it searches for aurora in the upper atmosphere of Saturn. As the spacecraft approaches Saturn, it performs a roll turn to sample the environment around the planet. Voyager 2 is extensively reprogrammed in flight, based upon the scientific discoveries of its twin spacecraft. Saturn's rings are targeted for special study during Voyager 2's approach. Sections of the braided F-ring are studied from different points of view to create three-dimensional pictures of the strands of the ring. Dark, spoke-like features in the B-ring are photographed as they move around the planet. Muted atmospheric activity in Saturn's cloud tops is monitored. Voyager 2 flies above the ring plane and crosses the plane just once, after its closest approach to Saturn. One important science objective is the photopolarimeter observation of the occultation of a star by the rings. Light from the star Delta Scorpii is measured as it flashes through the rings in the shadow of Saturn. The 2.25-hour experiment provided information on the number of ringlets, their densities and widths. The infrared interferometer spectrometer measures changes in the temperature of the moon Titus as it moves into Saturn's shadow. The circle around the moon represents the instrument's field of view. The rate at which Titus cools as it moves out of the sunlight provides clues to the composition and the history of the icy moon. Voyager 2 now moves to its closest approach to Saturn. Flying 63,000 miles above the cloud tops, the spacecraft moves into the shadow of the planet, and Earth and Sun disappear from view. Flying down and through the ring plane near the faint G-ring, Voyager's radio voice is cut off by the planet, then is heard again as the spacecraft emerges from the shadow to resume communication with Earth. High-resolution photographs of the planet and satellites are assembled from mosaics of images covering separate areas of each target. From a distance of about 58,000 miles, Voyager's cameras compose a 4-image mosaic of Titus. In the early hours of August 26, 1981, Voyager 2 left the Saturn system. After Saturn, Voyager 2 flew almost 2 billion miles on a 4.5-year journey to Uranus, which it encountered in January 1986. 3 years and 1.5 billion miles more take the spacecraft to Neptune in August 1989, completing Voyager's tour of the giant outer planets. Waynesville, North Carolina, looks like a lot of American small towns, right down to this Saturday morning scene at the Roper House. Actually, there is something very special going on here. This is Dee Roper and his son Stevie. Stevie was born 9 years ago with a very rare physical condition. Lacking sweat glands, his body had no natural way to cool itself. Until recently, too much physical activity or even limited activity on hot days could have been tragic for him. But thanks to the concerned efforts of a diverse group of people, Stevie now has a way to beat the heat. A liquid-cooled outfit based on NASA technology. This small pump and heat exchanger cools and recycles fluid through a vest and hat, a system similar to that used in astronaut spacesuits. Stevie can wear the outfit while exercising if it's convenient, or simply put it on intermittently to cool down. It's made a tremendous difference in his life, and it all came about because of Stevie's aunt, Tootsie Moody. She became so concerned with Stevie's inability to handle heat that she called NASA's research facility in Hampton, Virginia. They recalled a magazine article that talked about liquid-cooled garments being used by firefighters, pilots, and race car drivers. It's meant a newfound freedom and peace of mind, not only for him, but for his whole family. His performance in Sue Smart's 4th grade class at Central Elementary has also improved. Before the cool suit, he was constantly getting drinks or applying cool towels. Now, when he gets too hot, he simply dons the suit and continues working. But probably the most significant factor is that he's in school more often, because the suit has reduced his susceptibility to respiratory ailments like bronchitis or pneumonia. The effort with Stevie has been so successful that his aunt is now heading a national foundation. Its goal is to do the same for over 400 children in America with Stevie's condition, bringing space technology down to Earth. We join this week's look back to the flight of Faith 7 as astronaut Cooper blasts off on America's 4th manned orbital mission to test the capacity of man to be an effective part of a space control flight system. As the spacecraft reach maximum dynamic pressure, all systems are go. As it rises, it's acquired and tracked by radar. Its automatic control is switched to the ground station. In the outer atmosphere, the vehicle is tilted toward the horizontal course. The escape tower remains in position to pull the spacecraft away from the launch vehicle in an emergency. At about 2 minutes 15 seconds of flight, BECO, or booster engine cutoff, will occur. Animations will show events beyond camera range, as the Sustainer engines drive Faith 7 towards orbital speed and altitude when the spacecraft can escape with its own rockets and the tower is jettisoned. At 100 miles up at a speed of 17,544 miles per hour, SECO or Sustainer engine cutoff occurs. Faith 7 is inserted into orbit, and 1 second later it separates from the launch vehicle. Faith 7 was inserted into orbit exactly in the center of its programmed envelope. Using fly-by-wire controls, astronaut Cooper then turned the spacecraft so that it traveled with the retro rockets and the heat shield facing forward. This way, the retro rockets could be fired to reduce speed and end orbital flight if necessary. The small jets of hydrogen peroxide, which change the spacecraft's latitude, have no significant effect on the speed or path of the orbital flight. At 14 minutes 53 seconds flight time, contact was made with the Canary Islands tracking station. CAPSCOM is the capsule communicator in contact with the spacecraft at each of its many tracking stations. In addition, 28 ships and 172 aircraft were located around the world in pre-selected recovery areas. Contingency forces were also ready in case of emergency landing. An added advantage of having a man perform in a spaceflight environment was indicated by astronaut Cooper's ability to keep a detailed account of his flight on the onboard tape recorder. He was able to record details that simply did not appear on the instrument panels, for example, approaching his first night. He indicated that there was a bright blue band as the sun spread out widely. From the low point of the flight, 100 miles above Bermuda, to the high point, or apogee, 166 miles over Australia, the first orbit was nearly perfect. Capcom in Mexico gave astronaut Cooper and Faith 7 the go-ahead for 7 orbits. If all was well in the 7th orbit, he would get a go for 17 orbits, then for the full 22. Meanwhile, he began the first of several experiments. The first was the use of this slow-scan television camera to relay pictures to the ground, which relayed at the speed of 1 picture every 2 seconds. These pictures resulted from a transmission over Florida. 15 minutes before sunset on the 3rd orbit, Major Cooper prepared to eject this metal sphere or beacon for another experiment. This simple experiment was to see how well man could see flashing lights in space to help with rendezvous and docking procedures on future space programs. It's fascinating to look back from the new millennium and see how these very simple experiments build our knowledge and management of procedures in space today. Once ejected, the beacon assumed its own orbit, which kept it at varying distances from the spacecraft. Major Cooper wasn't able to see it on the 3rd orbit, but by the 4th it was clearly visible. Beyond 10 or 12 miles, the flashing beacon became less discernible. Also in the 4th orbit, a series of tests were begun to measure radiation in space. A field of fission electrons were trapped in the lower reaches of the Earth's magnetic field. They would be penetrated by the flight of Faith 7, Also on orbits passing over eastern South America and the South Atlantic Ocean. Primarily, the measurements were monitored by two Geiger counters located on the retropack. One of the Geiger counters surveyed a hemisphere-shaped area unobstructed by the spacecraft and unaffected by radiation scattered by its structure. The second measured radiation directly in the path of travel. Trapped electrons spiraling along the Earth's magnetic flux line were primarily the source of radiation. Several devices were used to measure radiation piercing through to the interior of the spacecraft. A pocket ion chamber, a film patch attached to the hatch of the spacecraft, a photographic emulsion pack carried on the instrument panel, and 4 film patches worn beneath the astronaut's pressure suit, one in his helmet, the other 3 on his body. The patches contained 2 types of film, one sensitive to protons, one sensitive only to electrons. Both the nature and amount of interior and exterior radiation at the Mercury orbital altitude were ascertained during the flight and found to be well below the level harmful to man, which I'm sure was a comfort to astronaut Cooper. Experimenting with the ability to drink water in a weightless condition proved to be successful, but Major Cooper had difficulty in transferring water, needed to make some of his packaged food edible. Experimental foods were freeze-dried and dehydrated so that adding water would restore their taste and consistency. Other foods were packaged in bite-sized bits. All sandwiches, brownies and other dessert-type foods were easily eaten. Other experiments were highly successful. For example, on the 6th orbit, astronaut Cooper clearly saw a 3 million candle power light shining up from Africa. Such a light was considered useful for future moon explorers to use on their return to Earth. He carried out several experimental photographic assignments, such as taking pictures of Earth's horizon, which may also serve as a navigation fix on longer space flights. Another photographic research project involved use of a 35mm camera to shoot 2 dim light phenomenon best observed just beyond the Earth's atmosphere. One is called the diacal. Lights believed to be weak reflection of sunlight from free electrons and dust particles. The other dim light phenomenon he photographed was the Earth's night airglow layer, a weak 3-colored band of light around the Earth. Time exposure with a 35mm camera would yield information on the height and intensity of these layers and on solar energy conversion processed in the upper atmosphere. Infrared photography of the Earth on black and white film was also performed for the Weather Bureau to obtain data for the design of improved television cameras for use in future weather satellites. From time to time, Gordon Cooper also shot color photos selected at random, including pictures of the Atlas Mountains of Africa and the Himalayas. Machines do fail, and on Faith 7, the autopilot had failed. Astronaut Cooper did not. Between the spacecraft's instruments, the men at Mercury Control, and Cooper, the decision was made that Gordon Cooper would have to fire the retro rockets and control re-entry by hand. Without a man to bring the ship down safely, the spacecraft and all its valuable data would have been lost. Each error of 1 second in timing would cause a 5-mile error in landing point. Cooper contacted another highly experienced pilot, John Glenn, to assist with the delicate procedures and timing needed to bring her down safely. At the 34th hour of the flight, John Glenn began the countdown. Astronaut Cooper had fired the retro rockets right on the second. He jettisoned his retropack. The tremendous speed of the spacecraft re-entering the atmosphere built up a temperature of approximately 3,000 degrees Fahrenheit. The ionized air cut off radio contact for a short time. Now it was a matter of waiting, hoping that Cooper would survive the fall, hoping that the chute would open and hold, hoping that his splashdown could be safely recovered. At this point in time, Many of the variables of liftoff and re-entry were barely known, and it was often an anxious wait to see just how the descent would end. Faith 7 was picked up by radar at 184 miles out and falling fast. Shortly thereafter, the main parachute was sighted. Splashdown. And so it ended, 34 hours, 20 minutes and 31 seconds. The flight of a man in space, 22 times around the Earth, traveling 540,000 miles, arriving home just 4.5 seconds from the designated time and just 4 miles from the drop zone. The flight of Faith 7 was over. A great deal of data was still to be gathered, from the immediate medical checkout of the astronaut before he emerged from the spacecraft to preliminary post-flight analysis. The mission seemed to prove man's capacity to be an efficient, functioning component of a spaceflight control system during a period of prolonged weightlessness. As a pilot, Cooper had come a long way from the time when he was 6 years old and allowed to handle the controls of his father's single-engine biplane to that day in '63 when he proved that man's valor and ingenuity was a useful and necessary part of a space control flight system. Astronaut Gordon Cooper was a hero in the old-fashioned sense of the word by entering into a realm of which he knew little and could control only marginally. Gordon Cooper risked his life at every step of the way in order to further the great space adventure and pave the way for the astronauts of today. Using 9 images taken by the Voyager 2 spacecraft, planetary geologist and visualization specialist created a computer-simulated flight over the southern hemisphere of Miranda. A geologically interesting moon of the planet Uranus, the flight takes us over a bewildering array of landforms. As we simulate flight over the terrain at altitudes of 3 to 20 miles, keep in mind that Voyager 2's closest approach to Miranda was more than 18,000 miles above the surface. That brings us to the end of this edition. We look forward to your company next time. But remember, we are out there. What we can and can't see is out there, and the mysteries between us, although seemingly insurmountable, are encompassed by a disappearing frontier.